Hello and welcome to this announcement event for the Platforms for Advanced Wireless Research program, also known as PAWR. I'm Mari Silby with US Ignite and also Program Director for the PAWR Project Office. US Ignite co-leads the project office with our partners at Northeastern University, and I'm here today as just one representative of the incredibly talented team overseeing 3 advanced wireless testbeds and soon to be a 4th. The $100 million PAWR program was created by the National Science Foundation for the purpose of accelerating fundamental research on wireless communications and networking technologies. It is funded by the NSF and an industry consortium of 35 leading wireless companies and associations. Today, we have 3 active platforms in the PAWR program. First is Powder Renew, a testbed based in Salt Lake City with a software-defined, fully programmable, end-to-end wireless network and massive MIMO capabilities. Second is Cosmos, a platform based in West Harlem in New York City and focused on millimeter wave research and innovative optical backhaul technologies. Both of these first 2 testbeds are generally available for research today. The third platform is AirPAW. AirPAW is based in the Research Triangle area of North Carolina, with a research focus on wireless communications and unmanned aerial vehicles, or drones. AirPAW will be generally available later this year. Finally, we're here today to announce the 4th PAWR platform and the first testbed focused on technologies for rural broadband connectivity. To make the announcement, I'd like to introduce our first speaker for today, NSF Assistant Director for the Computer and Information Science and Engineering, or SISE Directorate, Dr. Margaret Martinosi. Welcome.
Thank you so much, Mari, and good afternoon or good morning, everyone, depending on where you're listening from. So my name is Margaret Martinosi, and I lead the Computer and Information Science and Engineering, or SISE Directorate at the National Science Foundation. I'm honored to be a part of this important announcement. Having close family in Iowa, I've had the opportunity to visit the state many times, so although I join you virtually today, I very much wish I could be there in person. Today marks a milestone for us at NSF, our colleagues at the U.S. Department of Agriculture, and our private partners, as we announce this award to deploy the 4th city-scale wireless research testbed of the Platforms for Advanced Wireless Research, or PAWR program. Congratulations to PI Hongwei Zhang and the whole Ara team at Iowa State University and the city of Ames, Iowa, on being awarded this $8 million of NSF and USDA funding designed to support groundbreaking research to improve rural broadband. When we first launched the PAWR program in 2016, we had a vision of bringing together the public and private sectors to truly revolutionize our nation's wireless innovation ecosystem. We sought to catalyze developments of new wireless devices, protocols, and applications and services to enhance broadband connectivity around our country, and ultimately to sustain our nation's leadership and economic competitiveness around the globe. To accomplish this vision, over the past 5 years, we've partnered with more than 30 leading wireless companies and associations to invite academic and local leaders throughout the country to design and deploy these PAWR testbeds. Most importantly, we wanted to aid the research community, spanning universities as well as companies, to have access to the tools that they need to conduct important experimentation, in the wild, if you will. So ARA is the 4th PAWR testbed, and it specifically seeks novel solutions to reduce the costs and improve the availability of rural broadband, benefiting many underserved communities across the country. Research conducted with ARA will create new possibilities for experimenting with broadband's delivery models designed to lower deployment costs and extend coverage in rural America. The announcement of ARA comes at a crucial time. This past year, we've all seen firsthand the challenges of unconnected communities during the COVID-19 pandemic. Rural communities across our nation have struggled with access to education, telehealth services, telework opportunities, just to name a few. These challenges have disproportionately impacted rural communities amidst the pandemic. Despite the importance of broadband access, millions of households don't have access to high-speed wireless services, and many more lack the income necessary to afford these broadband services. The digital divide between rural and urban communities persists across all states and among many different demographic groups. Just as one example, in Linn County, Iowa, 15% of the households there don't have broadband access. And the average broadband costs in Linn County are higher in areas like that compared to more densely populated areas where the same amount of broadband equipment can cover more customers and thereby lower costs. So we need new solutions. Affordable access to broadband is becoming an essential necessity, similar to energy and water. And its applications are so far reaching in our modern world that they directly and indirectly affect all aspects of our lives. Broadband isn't just about internet access on its own. Rather, it's the key factor in developing and deploying innovative solutions in fields critical to our economy, like precision agriculture, education, health, cleaner energy, self-driving vehicles, and much more. Before I close, let me say a few quick words of thanks. In particular, the PAWR program, as was mentioned, is a $100 million public-private partnership that brings NSF together with other federal agencies and industry. So I want to acknowledge and thank the contributions of our colleagues at the U.S. Department of Agriculture and the 30-plus companies that have been with us, some from day one, as members of the industry consortium. I also want to acknowledge and thank the PAWR Project Office, which is funded by NSF and run by US Ignite and Northeastern University. This PPO manages the program as part of a cooperative agreement with NSF. Let me also thank the NSF team that has provided leadership to this program over the last 5 years. This hasn't been easy, and yet it's been wonderful to watch how this program has taken shape and is starting to have impact. I'm excited about the benefits that ARA will bring to the communities that it engages with. ARA's work makes me so very optimistic about our country's overall push to close the digital divide and ensure affordable broadband access for all. I look forward to seeing ARA and these benefits firsthand on a future visit to Iowa. Thank you. Mari?
Thank you so much, Margaret. Now, I'm pleased to announce that our next speaker is Director Carrie Castile of the U.S. Department of Agriculture's National Institute of Food and Agriculture, NIFA. NIFA is contributing an additional $1 million in funding to the ARA platform, and we are grateful for their support. Dr. Castile?
Thanks, Maury. I'm Carrie Castile, the director at the National Institute of Food and Agriculture, and pleased to provide remarks on a tremendous public-private partnership to address one of rural America's most pressing needs, broadband connectivity. Every aspect of life, whether you live in the city or a rural community, will be increasingly dependent on the ability to connect through technology. From automated tractors in the field to medical consultations at your local doctor's office, broadband access is and will be increasingly important and will be the great equalizer. It will impact our ability to attract businesses and industry to rural areas and determine educational offerings at our local schools in the future. We're so proud that USDA can lend our support to your research and vision and really appreciate the opportunity. Thank you so much.
Thank you so much, Dr. Castile. We really appreciate the support. Now I'd like to welcome one of our industry consortium partners to speak. Paul Challoner is Vice President of Network Product Solutions for Ericsson North America, which has been a committed and generous partner since the PAWR program launched. Paul?
Thanks very much, Murray, and great for the invitation to be here. So Ericsson is incredibly proud to be part of this PAWR initiative, and it complements the other PAWR initiatives we've been involved in, which is the airport drone initiatives that you mentioned earlier in North Carolina, which is actually in commissioning right now. So ARA provides really a unique opportunity to research 5G use cases, and Ericsson will supply network infrastructure equipment and services to support this initiative, providing commercial grade equipment into the research environment. It really gives a unique opportunity to experiment with many rural use cases. For example, exciting agricultural use cases, such as crop identification, where you need a high resolution video to be processed in the cloud to be able to identify a particular crop strain. Also, things like livestock tracking, which is maybe a more modest data requirement, but needs wide area capability. So we need to trade off capacity and coverage demands. So also it allows us to be able to connect to agbots or IoT connected tractors. So it allows us to be able to automate farm management. Also drones for precision agriculture, crop spraying, weed identification. I think it's my favorite use case where a drone has a camera, it identifies a weed in a field and can apply pesticides. So I think that's pretty interesting where AI technology is used for the identification together with the cloud. And so these different use cases really require different radio technologies. And so different bands, so low, medium, and high frequency bands with different propagation characteristics, different radio types. So for example, massive MIMO that provides the capacity, more classic radios that provide coverage, and trading off all of those combinations of radio technology that we see. It also needs to be highly programmable, an open environment, and providing advanced 5G capabilities like network slicing and ultra-reliable low latency communication. And this technology really helps us to understand how we can solve the digital divide and how we can apply what we learn here to solve it. And so it's not really just the digital divide, or sometimes talk about the homework gap. It's really what we think about as a mobility divide. And so it's not just coverage or connectivity to a farmhouse or a building, it's wide area connectivity to a field, for example, or a whole farm. So IoT use cases can be used across the whole farm environment to better automate that farm experience. And so this also provides an ability to have connected agriculture. It gives the side benefits of providing training in the farm environment, and which helps secure more employment for the agricultural environment in the rural case. So thanks again to the National Science Foundation, to PAWR and the Ara team. I'm really excited to look at the research output from this platform and discover more about the use cases and the radio technology that underpins it. This really will provide insights that we can put to good use to be able to create the digital villages and digital farms of the future to sustain the rural landscape in the future. Thank you very much, Mari. Back to you.
Thank you, Paul. And if you could bring that weed identification application over to my backyard when you're done with it, that would be helpful. Now, I have the pleasure of turning the stage over to the project lead for the newest PAWR platform. I, again, have had the pleasure to get to know Dr. Hongwei Zhang is the principal investigator for ARA, and he's here to share the vision for PAWR's rural broadband testbed based in central Iowa. Hongwei.
Right. Thanks, Mari. Thanks, everyone, for joining us today, and also for Paul, Carrie, and Margaret for sharing your thoughts and wishes. Also, just want to briefly, thank PPO, NSF, NIFA, and the Power Industry Consortium, and also the research community for entrust this effort with the ARA team. So Arnold, if you could bring up the slides, that'd be great. So the ARA project is led by colleagues from Iowa State University, University of California, Irvine, Ohio State University, and International Computer Science Institute. We actually have a website that's up and running. It's arawireless.org. You could find a lot of useful information there. So today here, I'm going to share a few high-level points about the ARA project, and also share a call for participation at the end. So next, please. We'll start with a video about ARA.
Almost 3/4 of the U.S. is classified as rural, and less than half of that area has access to broadband internet. Despite the nation's dependence on rural America for food and energy production, very little progress has been made towards providing broadband access to these rural areas. The Ara Wireless Living Lab is a first-of-its-kind, real-world wireless infrastructure for smart and connected rural communities. As a component of the National Science Foundation's Platforms for Advanced Wireless Research program, ARA will provide processes, activities, and organizations to engage in research, education, and innovation, and a pilot program for affordable, high-capacity rural broadband solutions. The Ara Wireless Living Lab will create a blanket of broadband coverage across nearly 600 square miles, a 3-county region of central Iowa from Boone to Marshall. The lab includes numerous school districts and 6 major rural communities. The project leverages existing infrastructure offered by partners Iowa State University, the ISU Research Park, the City of Ames, the Boone School District, Iowa Communications Network, Iowa Regional Utilities Association, U.S. Cellular, and others. ARA's combination of wireless access networks, long-distance high-throughput links, and low Earth orbit satellite networks will allow field testing and research of these new technologies, while also providing experimental broadband access to homes, schools, and offices throughout the Living Lab footprint. By supporting fundamental communication services that are shared across rural and urban applications, ARA enables field investigations of research questions, such as teleoperation of ground and aerial vehicles that are of interest to both rural and urban communities, but are difficult to conduct in urban settings in early phases of the exploration. Collectively, the Ara Wireless Living Lab's hardware and software systems enable cross-discipline, cross-community collaboration through research, education, and innovation. These collaborations are expected to generate not only scientific and technological foundations of advanced wireless, but also provide the pathways for real-world adoption.
Right, so let's move on to the next. So hopefully that gives you a very high level overview about the Ara vision. So at the foundation of the Ara Living Lab is the deployment of long distance high throughput communication platforms across the central Iowa, a good part of the central Iowa region. For instance, we have the Ara Hall to serve the middle mile solution, middle mile research platforms that embodies a heterogeneous set of long-distance, high-throughput research systems, ranging from optical links to millimeter wave to microwave, and all the way to new SATCOM platforms. For instance, one of the platforms here mentioned in the free space optical platform can offer capacity up to 160 gig BPS at a pole hop distance over 15 kilometers. Besides deploying these individual platforms in field at scale, they will also be architected so that they can actually support research that leverage spatial temporal spectral diversity to provide robust high capacity in the presence of imperfections in weather and other environmental factors. Next, please. So that's Ara Hall, and then there's, for the access network, we would also have deployment of high throughput COTS and SDR systems, ranging from low UHF massive MIMO solution to millimeter wave, and also other general sub 7 gigahertz solutions. They can provide capacity over 100 meg BPS at long distance for instance, for more than 10 kilometer radius. The access network platforms will also be architected so that they can enable bandwidth aggregation, channel aggregation, and bonding to provide high capacity access link to the field. They also enable research of in massive MIMO and also 5-layer solutions, as well as dynamic spectrum sharing in the field. Next, please. So through the deployment of these advanced access and backhaul platforms in real-world situations, Ara is expected to support a wide range of research. For instance, in long-distance, high-capacity backhaul to bridge the gap between the remote communities and the fiber endpoint. Also provide enable research in advanced wireless by studying massive MIMO and millimeter wave in rural settings. Also enable research in spectral innovation in both technology and policies. And with the deployment of edge and cloud resources, together with the access and fiber, we would enable end-to-end cyber infrastructure investigation in the field. Next, please. So as a living lab, Ara not only support wireless research, but also support investigation of wireless with application in mind, also the associated application research. For example, some of the applications that Paul mentioned earlier, they can be actually investigated and tried out here in the Ara deployment settings before we actually scale them up elsewhere. Some of the example applications we will focus on as part of this project would include high throughput robotic phenotyping, and also use cameras, network cameras for precision livestock farming, such as health monitoring, behavior detection. Also enable the exploration of automated agriculture, where high resolution image sensors can be integrated with edge and cloud resources in real time to enable real-time data analytics and feedback control, such as weight control that Paul mentioned. In terms of education, we'll also be investigating how to use AR-based ag delivery model to potentially transform the ag and rural education in general. Next, please. So through the deployment of advanced wireless platforms in the rural settings, Ara is going to enable research that can deliver technologies that has a huge potential to reduce the broadband, the rural broadband capex by a factor of 10 or more. By supporting emerging application areas such as precision agriculture, we can also incubate demand and increase the spatial density of the user devices in the rural settings. And by engaging the communities in the operation and deployment of the rural broadband services and infrastructures, we could also reduce the operation cost. So collectively, this effort will have a huge potential of making rural broadband as affordable as urban broadband today, and therefore hold a great potential for bridging the broadband gap between the rural and urban. Next, please. So to realize this vision and to enable the co-design of wireless and applications, we will be organizing a wide range of Living Lab activities that will empower the diverse communities in wireless application technologies such as sense and control, mixed reality, streaming, as well as end user communities to collaboratively co-shape this evolution of the wireless technology, rural broadband, as well as their applications in various application settings. So therefore, we very much welcome everyone to join us in this effort, and we will be reach out to the community on some of the upcoming, some of the events we're going to organize to help engage all of us to work together. So next, please. In fact, we actually have one event that we have planned that's going to be held just in about 1 week. We're going to hold the first Ara Research Community Workshop on June 30th and July 1st. We hope to see many of you there so that we can kind of get your feedback about the Ara design and make sure that we can actually maximize the utility of the Ara testbed for the broad communities. We also have a Google group that's set up, the Ara-users, Ara users. You can actually Google and find it. We would welcome you to join the Google group. That's going to be our online forum for kind of brainstorming discussions, also for exchange ideas and so on. We also welcome potential partners who will be interested in working with us in a very close fashion to shape this effort in the coming years. So if you may be interested, please reach out to us at partner@arawireless.org. Or if you have any general questions or suggestions, well, we look forward to hear from you at contact@arawireless.org. Thank you very much for your time and attention. I look forward to working with all of you. Thank you. Back to you, Mary.
Thank you so much, Hongwei. It's been a pleasure getting to know you over the last several weeks in particular, and we look forward to a very rapid start of deployment for the Ara platform. That wraps up the programming for today's event. For more information on the PAWR program as a whole, including the press release announcing today's Ara Award, please visit www.advancedwireless.org. For more information on Ara, as Hongwei said, please visit arawireless.org. Unfortunately, we're not able to take questions today at the live event, but we are happy to respond and take questions from anybody who is interested in getting involved from a research, from a partner standpoint, or just has questions about the platforms. We are happy to respond and share further details. We can be reached at info@advancedwireless.org. Congratulations again to the entire Ara team. Thanks to everyone for joining us, and have a great day.